For this circuit, S1 closes at t is equal to 0. Before that it was open, and then S2, the other switch, closes at t is equal to 2. So we need to find the expression for I. Of course, I before t is equal to 0 was 0. The I is the current through the inductor here, this one. So we need to find the expression of current for t is greater than 0 to 2 and then t greater than 2. These two we need to find. So let's look at the situation when S1 is closed and S2 is still open, that is between 0 to 2. So the circuit will become like this one. So 6 ampere here, 15 ohms still here. This switch is closed now, so 10 ohms, and that switch is open, the S2, so it's there, and this one is like that. So it's becoming 10 ohms here, 20 ohms here, and 5 Henry here. So we need to find this current, and we can say the current consists of two parts, transient plus the steady state. So when we look at the transient, it will have an exponential component with a constant there, so e to the power minus t over tau, and the steady state will be when this one reaches the DC, the steady state situation. So this one is short circuited, so of course the current will be the steady state current. Let's do that first here. Steady state will be just this branch and these two, they've been parallel, so current divider rule, 15 plus 30 here times 15 because it's current through here, so that gives us 645 into 15, so that gives us 2 amps. So that's the current, it's the steady state current. Now when we look at the transient here, I a e to the power minus t over tau plus 2, that's the steady state value, and the transient is when t is equal to 0, I is 0, so it becomes 0 here, a, this part becomes 0 plus 2, so a is negative 2. So the total current becomes, the steady state current becomes, of course, 2 minus 2 e to the power minus t over tau, so 1 minus e to the power minus t over tau. Now when comes tau, what is tau? It will be the resistance that the inductance C here. So that is of course these three resistance in series. So not only the resistance, L over R, so like that. So L is 5 here and the resistance is here the addition, so that's 30, 45, so that's 1 over 9. So this one tau is below, so it becomes in the denominator, so it becomes 1 e to the power minus 9t. That's the expression for t 0 to 2. Now when the second switch is closed, the first switch is already closed, so after t is equal to 2, the circuit becomes like this. So this one is again still 15 ohms there, this one there, 10 ohms there, this switch is closed and that switch is closed, so this resistance is shorted out. The 20 ohm resistance here is shorted out because this switch is closed, so we have just 10 and then 5, so we have here 10 ohms and then 5 Henry inductance. So we need to find this current. So now our expression becomes I transient plus I steady state again, and here let's do the steady state first again. So steady state current is again the parallel 6 and then 15 plus 10 times 15, so that's 90 here, and then this one is 25, so it becomes 3.6. so that's the steady state part. Now we will look at the transient part. So I transient plus 3.6 there. Now when we look at the transient, we have to, the expression will be like this, a again, new a, e to the power minus t minus 2, the t term has to be t minus 2. Since it starts at 2, it has to be t minus 2 over tau. This tau will be different, but I'm just writing still tau here, 3.6. Now this tau again will be, this time it will be L over R. So L is again, L is still 5, but R will be 15 plus 10, because that's the resistance it sees. So 5 and 15 plus 10, that is 25. So 1/5 there. And at t is equal to 2, which is the start, I steady state was, I was, at t is equal to 2, I was, if we look at this one, I will be actually 2, because when t is equal to 2, this circuit, this switch was closed, and this circuit was in steady state. So the current was actually this one, 2, because that's the current, since this was already in steady state. So just by current dividing rule, the current divider rule. So here we will have 2 at t is equal to 2. So this term will again become 0, this term, because t is equal to 2, and this is 3.6. So A becomes minus 1.6, 2 minus 3.6. So that's our A. So the expression now becomes very simple. It becomes minus 1.6 e to the power minus t minus 2 over tau plus 3.6. So 3.6 minus 1.6 e to the power minus t minus 2, and 1 over tau is 1/5, so this will be 5 here. So basically times 5. That's the expression for t greater than 2. Expression of I for t greater than 2, I can rewrite this like that. 1.6 there, e to the power the 5 ahead of that, t minus 2. So basically the strategy is always the same, just trying to figure out the break down the current in transient and then steady state. And steady state value we can find out by thinking about the DC situation, so shorting the inductance. And then transient is just from the boundary condition. The transient means, I mean the constant of the transient, so the A value. And of course tau is the L over R, and R is the resistance the inductance sees, the Thevenin's resistance for the inductance in a way. So yeah, this is just two situations, the two switches close at different times. So yeah, I hope this one is a good example.